Hi, Laura. So I'm going to go through a lesson that I've done with my students, and it may be a little bit different than yours. So if there's parts of it that you guys never ever covered, or it's not in your book, then you have to bear with me a little bit. But I'm going to go with the background that I know that I've worked with these kinds of problems that you have that was sent by your grandmother. Okay, shortcut formulas. So let's say you have 9 players who are going to play in baseball, and you want to know how many lineups are possible. Well, if I have 9 players in a game, so I have 9 players. Well, for my first person, I have 9 people that can go first. And then the second batter, I have 8 choices. And then the third batter, I've got 7 choices. And I can keep going all the way down till I use them all. There is a shortcut formula for this. It's called a factorial. This is 9 factorial. So what a factorial is, when you see that little exclamation point after the number, it takes the numbers and it takes that number and multiplies all the numbers less than it all the way going down to 1. So that means there'd be 362,880 ways to take 9 people and arrange them. So here, order matters, and that part is really important. Now, let's say the team actually had 20 baseball players, and I want to know how many different lineups are possible. Well, I can do the same idea. For my first person, I've got 20 choices for the first one, then 19, then 18, then 17, going all the way down until I've used 9 of them. So this is my first choice, my second, my third, my fourth, fifth, 6, 7, 8, 9. Now, it's not too bad, to have to calculate this out, but in terms of, using a calculator, certainly would want to use a calculator for it, just kind of going over and keeping track of what you have. But there is a shortcut when we work with the idea of factorials. If I had 20 factorial, I need to see about getting rid of anything that's less than the 12. So what happens if I use this kind of a formula? It's 20 factorial, which means 20, 19, 18, 17, 16, all the way down to 1. And I do 20 minus how many people I'm actually picking. So I'm doing 9 people. It's what I'm picking. For a baseball game, you have 9 players. I'd have 20 minus 9. So what happens is you get 20 factorial over 11 factorial. And what occurs, if I write it all the way out, 20 factorial will be 20 all the way down to 1. 11 factorial is 11 multiplied all the way down to 1. And then these guys, 11 over 11, that equals 1. 10 over 10, that equals 1. 9 over 9 equals 1. And so on. All of these basically are going to reduce to 1, leaving me just that combination right there. So that helps to explain when I get to another formula a little bit later, where we're going to try to see about reducing and then simplifying. So permutations is what we just got finished doing. Here, the formula for a permutation, which again you may not have in your book, may come up later, but what it does is it takes how many items you have, that's n, and you want to know how many different arrangements you have of r items. And that's where the r comes in. And here's the formula. It's n factorial over n minus r factorial. So in the baseball player ones, n was 20, r was 9, so I did 20 over 20 minus 9. That's how I got 20 factorial over 11 factorial. So permutations here, order matters. Things, keywords like arrangements, permutations, orders, lineups. So we have 25 people at a banquet. Head table has 5 seats. I wonder how many different arrangements of these people. Well, most of the time, this is probably what you did in your class. You may not even looked at permutations. I would say I've got 25 for my first one, 24 for the next, 23, 22, and then 21. And that would give me my answer. I just go through and I just keep reducing it by 1 until I have 5 items. Now, as a shortcut, we could make this as 25 permutations of 5. Formula-wise, this would have been 25 factorial over 20 factorial. And what happens is I go 25 down to 21, and then everything from 20 down to 1 over 20 down to 1, those are all going to reduce, basically all becoming 1s. And I'm left with just this combination up there. So when you're working with this combination, n and r, n is always going to be bigger than r. So that's 25p5, 25 factorial over 20 factorial. Now, on the problems you were working with, you have order mattering. So the first thing is you got to think about, does order matter? So with permutation, order of selection was important. In most cases, order doesn't matter. So for example, if you're going to go over and 5 people from your class were going to be picked to go on a special trip, you don't care if you're picked first or fourth or fifth or when. You just want to be picked. So the order doesn't matter. Same thing happens with most kinds of games of chance, like being dealt cards, if you're dealt a flush in poker, or having lottery numbers come up, or looking at the probability of like a baseball player getting 3 hits and 5 at bats. Doesn't matter when he got the hits, just did he get 3 out of 5. So combinations, keywords are combinations, groups, sets. Formula that I typically use is written this way as n choose r is the way it's written, and using the factorial notation, again, which I'm not sure if they're showing you this yet, but that's the formula that gets used, and I'm going to explain why it works in a little bit. In yours, you're seeing this kind of notation. That's what I saw in your picture. And we're going to go to Pascal's triangle to kind of look at it from this standpoint. So I wanted to give some background information before I jump into Pascal's triangle. So that may have been helpful or not, we'll find out. Okay, so this is the Pascal's triangle that you had on your little picture that was sent to me. So understand how it's built. This row, the row for Pascal's triangle, if you look down this part right here, oops, came off my pad. If you look through this part, these are the rows. So this is the first row, second row, third row, fourth row, fifth row. The top row is row 0. Okay, and that's going to be important because we're going to use it for different kinds of problems. Okay. Now, to get the next row, well, the first number is a 1. And then these two numbers, if you add these two numbers together, you'll get 6. Add these two numbers together, you get 15. Add these two numbers, you get 20. Add these two numbers, you get 15. Add these two numbers together, you get 6, and then 1. That's how Pascal's triangle is built. So those are the numbers. And then if I went to my next row, well, it's going to go 1, 7, 21, 35, 35, 21, 7, and 1. Just add the two numbers above it to get the next number. Now, for any particular row, you can find what the position is. This N stands for the row. R is position. When you look at the positions, this is the 0 position. First, second, third, fourth, fifth, sixth, seventh. That's the way it goes. So if I look at 7, choose 5 is where you read that. 7, choose 5. I go to the 7th row. That's the one right here. That's a 7. And I want to get the 5th element. We'll start counting where you see the 7. That's where you want to count 1, because this one's actually 0. So that's 1, 2, 3, 4, 5. This equals 21. Now, from our formulas, when you see this formula, which may or may not be in your book, it is 7 is n, r is going to be 5. So I've got 7 choose 5 It's 7 factorial over 5 factorial over 7 minus 5. So that's what the n minus r is. Now, the important thing when you look at this, look at the numbers. Here's the number. Here's the r. So there's the 7. Goes to here. The 5 goes to here. And to figure out this number, 5 plus 2 equals 7. So these two have to add to 7. This doesn't become 7 factorial. It doesn't work that way. It's 5 factorial over 2 factorial. So if we simplify this, this is what we have. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. Here's 5 factorial. Here's 2 factorial. These will all reduce to 1. I've got 7 times 6 divided by 2. So the 2 and the 6 will reduce to 3. I got 7 times 3, that equals 21. So that's one way, without having to actually expand the whole Pascal's triangle if you're just looking for a particular piece. So this also represents, let's say you've got 7 people who have performed really great, but there's only 5 prizes. So they're going to randomly draw 5 names. There's 21 different ways of different combinations of 5 people who could have won. And that's what that kind of corresponds with. So that's the way most probability problems work. Now, one of the parts you're using is to use it with an expansion. So we were looking at x plus y to the 6th. Well, what happens here is the numbers that you're seeing in the column, in the row that's red, that's the 6th row, those are going to be the coefficients. If I expand out x plus y to the 6th, look at the way the numbers go. It goes x to the 6th, the x is reduced by 1, and the y is increased by 1. So x to the 5th, y to the 1st, x to the 4th, y to the 2nd, x to the 3rd, y to the 3rd. Each of these numbers, notice, look at the numbers right here. If you add them together, 3 plus 3 is 6. 2 plus 4 is 6. 1 plus 5 is 6. They all add up to 6. The coefficients are what's going to go in here. So that means this is 1, 6, 15, 20, 15, 6, and then 1. So that was one of the problems you had. Okay, so another problem I saw you had was working with the idea of repeated values. So I want to look at the arrangements of the letters for banana. So what you would do is you take these arrangements, the B-A-N-A-N-A, and I go, I got 6 letters here. So I've got 6 choices for my first letter, 5 for my next, 4 for my next, 3 for my next, 2 for my next, and then 1. But the A's repeat. So what happens here is I have to divide out all different ways I can rearrange the A's. Well, I've got 3 choices for the first A, 2 choices for the next, and then 1 for the last. And I've also got 2 N's. So I got 2 choices where the N happens, and then 1 choice for the other one. So as a formula, it's 6 factorial over 3 factorial times 2 factorial. So 6 letters, and I divided out my repeats. So I got to divide out all different ways of rearranging A because it's going to be exactly the same. I got to divide out the ways of rearranging the N's because it's going to give me the same word. So another kind of an example, and you have several of these, so when you're working with them. And it ends up being 60. So if I was to actually reduce this, 3, 2, 1, 3, 2, 1, 2 and 4, that becomes 2. So I have 10 times 6 is 60. That's if you had to do it by hand. So this wasn't a problem on yours, but it still works the same way. So a bag contains 10 candies. You have 5 Snickers, 3 of them We have 5 Snickers, 3 Baby Ruths, and 2 Milky Ways. You're going to give the candy to 10 children. And I want to know how many different ways we give out these candies. Now, a student, one person who gets a Snickers, it doesn't matter. 5 of them are going to get Snickers. So if they traded Snickers, it doesn't make a difference. They're all going to, whoever gets a Snickers got a Snickers. Well, what we have here is we've got 10 candies, and I've got to divide out the repeats. And that's basically what we're doing. So I've got 10 factorial. I'm dividing out the different arrangements of the Snickers. There's 5 of them. Dividing out the different arrangements of the Baby Ruths, and dividing out the different arrangements of the Milky Ways. Now notice right here, 5, 3, and 2, those are all, if I add up all different combinations, right, 5 plus 3 plus 2, it adds up 10. This one I could have done the same thing. I had 1b, so I could have said times 1 factorial and got the same result. Now, something that's also kind of important when you're working with it, 0 factorial is a tough one. 0 factorial they define as 1. So if they are using factorials, be aware, and that's what's going to happen. Now, one of the problems you had them all the same. Well, there's only one way of having them if they're all the same. So I'm going to look at the last few problems you had. Okay. And they're asking you to do things like, thinking about different ones. So like you had the one was dad, dad. Well, we have 6 letters. There's 4 D's and 2 A's. So you'd have 6 factorial divided by 4 factorial divided by 2 factorial. Now, if they haven't shown you factorials, if it's not in your book, you don't see that little exclamation point, then you're just going to go 6 times 5 times 4 times 3 times 2 times 1 divided by 4 times 3 times 2 times 1, and then times, also on the bottom, 2 times 1. And that's where you're going to see different arrangements. Then it asks you, write about it. Explain why for any n's that make sense, if you do n, choose 0 equals 1. Well, if they have shown you the formula for like n choose 0, if you've seen, if they've given you n over r is equal to n factorial over r factorial times n minus r factorial, and I'm doing n choose 0, well, then what happens if I've got n and I've got 0, well, now I've got n factorial, 0 factorial, then I've got n minus 0 factorial. I get n factorial over n factorial. That equals 1. So that's looking at it from a standpoint of that. That's why I thought maybe they had introduced the factorials as part of the problem. Okay, other parts of the problems you may have seen. 42 people have applied for a job. The company must select 6 people. We want to know how many, write an expression that will do it. Well, that's 42 choose 6. So if I got 42 people and I want to choose 6, so the expression is 42 choose 6. Now, if you have to calculate it out, what you would have is you'd have 42 factorial over 6 factorial, then do 42 minus 6. So I end up with 42 factorial over 6 factorial. And then these two right here, these two numbers are going to add to 42. So that's 36. 6 plus 36 equals 42. If you had to simplify it out, write out the 42s until you hit 36. The rest are going to reduce. And then you can reduce with the 6 factorial and then try to work the problem from that point on. Okay, I'm going to show a couple other problems that may or may not come up because I'm not sure if you have additional pages. So, looking at combinations. So now how many different ways can I have a 5-person committee formed from 20 people? Well, this one, I use this notation in my classes as 20 choose 5. For yours, you would have 20 choose 5 this way. Now, if you may have probability problems, so we can do different kinds of things. So I'm going to use the combination formulas now, the ones with the C, because it makes more sense. And it's easier to work with when you see it with the C. I've got 20 people right here, and it originally consisted of 12 women and 8 men. And the committee, I want to know how many ways can I get 3 women and 2 men chosen. Well, from the 12 women, I'm going to choose 3. From the 8 men, I'm going to choose 2. Out of 20 choosing 5. So this is different ways that I can get 3 women and 2 men. And I want to know the probability of this happening. Then these are the ways I can have that happen over my total possibilities. Now there's a little trick here too. If they give you problems like this, 12 and 8, add to 20. 3 and 2, add to 5. So that's when you're doing things like poker problems and other ones. So hopefully this is enough and it gives you the background you need for doing the problems. If you have additional questions, then feel free to send a text, and hopefully this helps out.